You think you know stars. You chart their fiery births, their long burning lives, their dramatic explosive deaths. But what if everything we thought we knew was a cosmic lie? What if, hidden in the deepest, most violent stellar nurseries, the universe forges an abomination so profound it rips the rulebook of physics to shreds? Imagine a star, a monstrous bloated red giant, with another impossibly dense neutron star slammed into its core, violently beating inside it, a heart of pure degenerate matter fueling its impossible existence. This isn't just theoretical, it's a terrifying, beautiful monster that shouldn't exist, yet the cosmos might be hiding them right under our noses, defying every law we cling to. We chart their lives, from the swirling nebulae where they ignite, fusing hydrogen into helium, then heavier elements, until their colossal cores finally exhaust their fuel. For the truly massive, those stellar titans, at least 8 times the mass of our sun, this core collapse triggers a supernova, an explosion so spectacularly violent it briefly outshines entire galaxies, tearing apart the star's outer layers. What remains is a cosmic ghost, a neutron star, a city-sized sphere of pure degenerate matter, so impossibly dense, a single teaspoon of its material would weigh more than Mount Everest. It's the universe's ultimate diamond, born from cataclysm, an inert, silent monument to stellar death, destined to drift through the cold, indifferent void. But what if that's not the end of the story for this cosmic diamond? What if, instead of fading into eternal solitude, it finds itself locked in a deadly gravitational dance with another dying behemoth, a red supergiant, already swelled to 1,000 times the size of our sun, its outer layers so diffuse they barely cling to its failing core? This isn't just a close encounter. This is a forced, inescapable embrace, a cosmic car crash in slow motion, played out across millions of years, an event so rare and so extreme, it shatters our fundamental understanding of stellar evolution. The most likely scenario for this impossible union begins in a binary star system. 2 massive stars, born together, live out their lives in a cosmic waltz. One star, more massive, burns through its fuel faster, detonates as a supernova, and collapses into a neutron star. Its companion, still burning, eventually swells into that enormous red supergiant. But instead of the newly formed neutron star being flung away by the supernova's kick, it finds itself caught in its companion's expanding gaseous embrace. Now, imagine that neutron star, its gravity an invisible monstrous fist, not merely orbiting, but punching directly into the diffuse cloudy envelope of its supergiant companion. This isn't a gentle merge, it's a brutal, one-sided battle. The neutron star, with its unimaginable density and crushing gravitational field, rips through the supergiant's outer layers like a bullet through a colossal, incandescent cloud. But even a cloud creates friction. As the neutron star plunges deeper, it slams into denser and denser plasma. The supergiant's immense gaseous body fights back, generating a colossal drag force that bleeds orbital energy from the neutron star, forcing it to spiral relentlessly inwards, deeper and deeper, faster and faster. It's a cosmic cannonball, losing momentum, but gaining purpose, aimed straight for the supergiant's already struggling, exhausted core. This isn't a gentle coalescence. This is a violent engulfment. The red supergiant, already teetering on the brink of its own demise, becomes a gargantuan, unwilling trap. The neutron star, a ravenous gravitational beast, doesn't just hide within its host. It devours the supergiant from the inside out. It carves a path of superheated destruction through the star's inner layers, stirring the stellar cauldron to temperatures and pressures that defy comprehension. The supergiant's original, inert core, a relic of its former glory, is utterly obliterated, consumed by the alien invader. The neutron star doesn't just settle in, it becomes the new, perverse, and impossibly dense heart of the red giant. Its crushing gravity and the sheer, raw violence of its descent fundamentally altering the very fabric of its host. The normal laws of stellar evolution, meticulously charted by generations of astrophysicists, scream in protest. But the universe, in its terrifying, unyielding indifference, simply forges ahead, creating a hybrid monster that rewrites every chapter of its own biography, a stellar chimera born from an act of cosmic violence. Now, if you thought the birth of a Thorne-Zytkow object, a TZO, was mind-bending, prepare yourself for the truly bizarre existence it carves out. Picture the impossible, a neutron star, a relic of stellar death, not floating in the vacuum of space, but submerged deep within the churning, incandescent plasma of a red supergiant's core. This isn't just a cozy fit, it's an inferno beyond imagination. The conditions inside this stellar hybrid are so extreme, so utterly alien, they make the surface of a neutron star, already a place of unimaginable crushing gravity and density, seem like a balmy beach. The neutron star, with its truly monstrous gravitational field, doesn't just sit there, it devours its host from the inside. Imagine trying to hold a super dense black hole inside a balloon. That's the scale of the struggle. The supergiant's inner layers, normally in a delicate balance between outward thermal pressure and inward gravitational collapse, are now subjected to the neutron star's insatiable hunger. This alien heart constantly sucks in surrounding plasma, a torrential downpour of hydrogen and helium from the supergiant's core. This isn't just a feast, it's a forced, continuous accretion, a cosmic feeding tube jammed directly into the heart of the larger star. As this gas slams onto the neutron star's surface, it doesn't just fall, it accelerates to insane velocities, heating up to billions of degrees. This creates an unimaginable internal furnace, a secondary power source raging deep within the red supergiant. Normal stars generate energy through nuclear fusion in their cores, a relatively stable, slow burn, but the TZO's neutron star core generates energy through a mechanism called accretion luminosity. It's the sheer kinetic energy of falling matter converted into heat and radiation, and it's unbelievably efficient. This internal inferno, this alien heartbeat, pumps out immense amounts of energy, far exceeding what the supergiant's own failing nuclear reactions could ever hope to achieve. This isn't just a minor tweak. It fundamentally rewrites the supergiant's inner workings. The neutron star, acting as a superpowered gravitational blender, continuously stirs and mixes the supergiant's core material. Think of a giant cosmic washing machine, churning plasma from the very center of the star outwards, and then pulling fresh material back in. This violent convection, driven by the neutron star's relentless energy output, drags material from the supergiant's deep core, where heavy elements might have settled, and brings it to the surface, and vice versa. It's a complete upheaval of the star's internal structure, a cosmic re-engineering project on a scale that beggars belief. The star struggles, visibly, to contain this alien heart. Its outer layers, already distended and cool, are now indirectly heated by the neutron star's monstrous energy output. The supergiant, instead of slowly fading, finds itself re-energized, its lifespan dramatically altered, but also inherently unstable. It's a star living on borrowed time, its very existence a testament to a cosmic anomaly. The TZO isn't just a star with a hidden secret, it's a star transformed, its identity shattered, its internal processes hijacked by an uninvited, impossibly dense guest. Its surface might look like a regular red supergiant to a distant telescope, but beneath that calm exterior, a titanic struggle rages, a cosmic horror maintaining its impossible equilibrium. If you're finding this cosmic strangeness as captivating as I am, consider smashing that like button and subscribing. It truly helps us bring these mind-bending secrets of the universe directly to you. Now back to the hidden heart of the TZO. Now, this is where the Thorne-Zytkow Object transforms from a gravitational anomaly into a cosmic alchemist's forge. The sheer unholy conditions created by that neutron star heart beating inside a red supergiant aren't just for show. They trigger nuclear reactions unlike anything seen in any other star in the universe. Imagine a pressure cooker, but instead of stew, it's cooking up elements that defy stellar logic. This is where the universe reveals its hidden, forbidden recipes. The incessant, violent accretion of the supergiant's plasma onto the neutron star's surface creates temperatures and densities that are a perfect storm for exotic nucleosynthesis. Normal stars build elements through a process called the S process, slow neutron capture, where atomic nuclei gradually absorb neutrons over long periods. But inside a TZO, the conditions are so frantic, so extreme, that they enable what's known as the rapid S process, and even more remarkably, the R process, rapid neutron capture. Think of it like this. In a normal star, neutrons are like slow, cautious builders, adding bricks one by one to an atomic nucleus. In a TZO, the neutron star is constantly spewing out a torrential flood of neutrons, slamming into nuclei at breakneck speeds. This rapid, uncontrolled bombardment forces atomic nuclei to absorb multiple neutrons almost instantaneously before they have a chance to decay. This creates incredibly unstable, neutron-rich isotopes that quickly undergo beta decay, transforming those excess neutrons into protons, thereby creating new, heavier elements that are rarely, if ever, forged in the hearts of conventional stars. This isn't just about making more iron or nickel. This is about conjuring elements from the very edge of the periodic table, elements that are astronomically rare or even thought to be impossible to form in stellar interiors. We're talking about chemical signatures that scream, something truly wrong is happening here. For instance, a TZO would be a factory for anomalous amounts of lithium, 7-Nosh, an isotope that's usually destroyed in stellar interiors, but is somehow protected and even generated in the TZO's unique convection. Then there's Thorne-Rubidium, an element typically found in cooler outer stellar layers. But in a TZO, it gets dragged deep into the neutron star's inferno, cooked and then violently recirculated. But the real giveaways, the screaming sirens of a TZO's presence, would be elements like molybdenum and other heavy neutron capture elements, especially those found in the range between iron and lead. These are the cosmic fingerprints of rapid neutron bombardment, the telltale signs that an R process, usually reserved for the most violent events like supernovae or neutron star mergers, is somehow occurring continuously inside a living star. It's like finding a blacksmith's shop inside a giant living whale, utterly incongruous, yet undeniably there. Astronomers, armed with their powerful telescopes and spectrographs, hunt for these spectral fingerprints. They analyze the light emitted from distant stars, breaking it down into its constituent wavelengths, each a unique barcode, revealing the star's chemical composition. When they find a red supergiant with an utterly baffling overabundance of these specific, heavy neutron capture elements, far more than any conventional stellar process could explain. It's like a cosmic alarm bell. It's the universe whispering, look closer. Something unnatural is lurking here. The detection of these specific anomalous elements is our most powerful weapon in the hunt for Thorne-Zytkow objects. It's not about directly seeing the hidden neutron star. It's about reading the chemical scars it leaves on its host. It's the ultimate detective story, where the clues are scattered across billions of light years, etched in the very light, reaching our instruments. And every time a new, strange spectral signature is detected, the possibility of finding one of these cosmic chimeras, these stellar abominations, inches closer to terrifying reality. The Thorne-Zytkow Object, this cosmic chimera, is a transient titan, a stellar aberration living on borrowed time. Unlike a stable, long-burning main sequence star like our Sun, or even a typical red supergiant that slowly fades, the TZO exists in a precarious, violent equilibrium. Its lifespan, though still measured in millions of years, is fleeting compared to the cosmic eons of other stars. It's a spectacular, unstable act of defiance against the universe's natural order. And like all such acts, it must eventually come to a cataclysmic end. So, what happens when this impossible hybrid can no longer sustain its internal struggle? The fate of a TZO is still a subject of intense theoretical debate, a cosmic choose-your-own-adventure, where every path leads to a spectacular, terrifying conclusion. One prominent theory suggests that the relentless accretion of matter onto the neutron star core, combined with the extreme internal pressures, eventually pushes the entire system past its breaking point. The neutron star, having gorged itself on the supergiant's guts for millions of years, might eventually become too massive to sustain itself. We know that a neutron star has a maximum mass limit, the Tolman-Oppenheimer-Volkoff (TOV) limit, roughly 2 to 3 solar masses. Beyond this point, even the incredible degeneracy pressure of neutrons cannot resist gravity's final, crushing embrace. If the neutron star inside the TZO accretes enough material to breach this limit, it would suffer an ultimate, terrifying collapse, not into a smaller, denser object, but directly into a whole black hole, nubby. This wouldn't be a gentle transformation. The birth of a new black hole inside a star would unleash unimaginable gravitational forces, tearing the entire TZO apart from the inside, triggering a unique and profoundly energetic type of supernova, unlike anything we've ever observed. Another possibility is a more gradual, but equally dramatic, demise. The intense, violent convection driven by the neutron star's internal furnace might eventually strip away too much of the supergiant's outer layers. Imagine the supergiant literally being boiled away from the inside, its outer envelope shedding into space over millennia. This slow, agonizing death would eventually expose the naked neutron star, leaving it once again adrift in the cosmos, a scarred survivor of an impossible union. The supergiant would simply vanish, leaving behind its alien heart. Then there's the truly explosive option, a unique kind of Type II supernova. While most Type II supernovae are triggered by the core collapse of a massive star, a TZO supernova might be different. The continuous rapid neutron capture processes, the constant churning of exotic elements, and the sheer instability of having a neutron star as a core could lead to a sudden runaway nuclear reaction or a rapid loss of stability, causing the entire star to detonate in a flash of incredible brilliance. This would be a cosmic fireworks display, born from a paradox, spraying those anomalous heavy elements across the galaxy as a clear, unmistakable calling card of its impossible existence. The extreme rarity of Thorne-Zytkow objects means that finding even a single one would be a monumental discovery, a paradigm shift for astrophysics. It would force us to fundamentally rewrite our textbooks on stellar evolution, adding a bizarre, violent, and utterly unexpected chapter. It would prove that the universe, in its infinite complexity and brutal indifference, is capable of forging objects that defy our most sophisticated models, pushing the boundaries of what we believe is possible. These are not just theoretical curiosities, they are screaming testaments to the universe's capacity for the truly outlandish, challenging us to look beyond the obvious and hunt for the hidden, transient titans that reshape our understanding of cosmic existence. We began this journey by challenging our most basic understanding of stars. We dove into the impossible heart of a Thorne-Zytkow object, a red supergiant with a neutron star for a core, a cosmic chimera born from a violent, gravitational embrace. We saw how this monstrous union forges elements that defy stellar logic, leaving spectral fingerprints that whisper of its impossible existence. And we contemplated its inevitable, cataclysmic end, a final, explosive act that would spray its bizarre, heavy elements across the galaxy, a testament to its brief, violent life. But the TZO is more than just a theoretical curiosity. It's a profound challenge to our cosmic arrogance. For generations, we've meticulously charted the lives of stars, confident in our understanding of their birth, evolution, and death. The Thorne-Zytkow object rips that neat narrative to shreds. It reminds us that the universe is infinitely more inventive, more chaotic, and more terrifyingly beautiful than our most brilliant equations can ever fully capture. It is a stark, incandescent reminder that even in the most familiar corners of the cosmos, the truly alien can lurk, hidden in plain sight, waiting for us to develop the instruments and the imagination to uncover it. The hunt for TZOs is a testament to humanity's relentless pursuit of the unknown. It's a quest driven by the tantalizing possibility that somewhere out there, a star is screaming a secret that could rewrite our entire understanding of how matter behaves under the most extreme conditions. It forces us to confront the limits of our knowledge, to push beyond the comfortable boundaries of accepted physics, and to embrace the awe-inspiring, sometimes existentially terrifying reality that the cosmos is still, overwhelmingly, a mystery, and perhaps that is its greatest gift. Tell me what you liked or disliked about this video. What do you think could be changed to make it better? I read every comment and will respond to every suggestion.